Okay, let us go ahead and get ourselves started this morning. Today, if you can, go to the coursework website and download from the Session 6 folder, the Session 6 Dynamo examples. That'll help us get started with some of the things we're going to be doing in class today. And as we get going, what I love to do is sort of recap a little bit about where we were last time and kind of pick up some threads from where we were. Last time we were looking at the whole issue of really placing adaptive components, and we spent the first part of the class really just looking at how we can use adaptive components to change their form, to go ahead and create forms or place panels on forms where the shape could be somewhat irregular, but that the component has certain key placement points that we want to map to points on a surface that can change. And the components can adapt themselves very, very smartly to going ahead and reforming as need be. It's kind of a whole special class of components. It's really very, very powerful. In terms of where we were last time, the first half of the video recorded just fine. The second half didn't, but I think that actually we'll sort of start back in kind of finishing up some stuff that we were doing last time, and it'll get us a chance to kind of get all synced back up and get back in the same place with everyone. And in terms of things that are going on elsewise and thinking about the overall class form, the assignment 1 is due today. I think, are most people in pretty good shape on that? Any questions? Just your last name, assignment 1, all that, and put it up on the course or in the Dropbox on the coursework website. That would be fantastic. Okay. And then in terms of where we were last time, there were a couple key things we sort of learned about. We learned about a couple new nodes. The list node, which was really good for creating index lists. The formula node, which was very good for creating formulaic relationships between a lot of different variables. So as opposed to building a lot of nodes, being able to type in almost an Excel-like formula language to tie them together and get some results. We learned about the watch node, and they were sort of very good functions just to really increase our scripting efficiency. For adaptive components, we looked at the whole notion of creating forms, dividing the surfaces up into different grids, and then mapping components onto those forms. And we specifically looked at an example of placing this beam sort of components, almost as ribs, like instead of fish, something like that, as we were going through and changing the form shape or kind of the number of ribs. The beam would go ahead and remap itself to that. Okay. Where we're going to pick up on that is we're going to keep on going with the adaptive components and really dig into the whole issue of really dividing a surface and then adding panels to a surface, because we have been going ahead and just sort of placing those initial elements along kind of some curve that we were defining. We're going to pick up the whole thing of basically taking a surface and dividing it up into a whole different series of grids that we can then use to go through and determine where either elements are going to get placed or panels are going to get placed. But look at those two things and kind of break that apart in some detail. We're also going to go ahead and move forward into actually the notion of having our models respond to the environment. We'll specifically look at an example of really how we can figure out where the sun's path is at any time, and then based on where the sun is in the sky, go through and have our geometry respond to that. Okay, so panels can move and change the direction, things can open and close, apertures can change the size of what's going on, but we can have things respond to really where the sun is in the sky at any particular time of the day or time of the year. Okay, so let's go ahead. I'm going to get started with the whole thing of dividing the surface. And for people who were here last time, this will look a little familiar, but we'll go through and hopefully just use it as a foundation for where we're going to be building today. And let's go. I'm going to go to dividing a surface, open that up, and just take a look at that so that we can use it just as a foundation. So the idea here is that we're going to start with a surface. It could be really any surface, and based on that surface, we're going to start breaking it up into a grid that we're going to apply not only sort of beam sort of elements to, but also panels to. And if you want to take a look at that surface, okay, I'm looking at 6.1. If you go to massing and site, and we actually show the masses, you'll see you can actually take a look at that surface. So it's actually just a mask surface. And if you want to edit that surface, please feel free to do that too. It's really just a part that I brought in with a Revit family. And if you want to edit it, you can choose it and say edit the family. And you'll see, here's how it's defined right now. It's really just a surface that's defined by 3 different curves with 3 different points on each of the different curves. And if you want to change that, we can change this formulaically, or we can just change this by directly manipulating it. Either way works. I can just start grabbing some of those points. And as I'm grabbing those points, what I'm really doing is I'm just stretching and deforming that surface. Okay, so we could have done this just directly with Dynamo, but in this case, we're sort of assuming a model where someone's done some surface modeling. They might have been creating this in Rhino, or they could have created it in sort of any other application that could have created some nice surface for you. So again, I'll just stretch this out, kind of make it a little bit different. Okay, but that's basically the surface. And once you have the surface, whichever surface it is, whether you want to keep my original surface or kind of keep on mucking around with it a little bit, feel free to drop it back in there. And if you want to reload that back into the project, please do. And I'll override it. Let's give me a slightly different surface. Now at this point, the surfaces here, there are actually some adaptive components that were placed based on the prior version of the surface. If I really want to be good, I should probably go through and just eliminate them because I'm going to recreate them based on the surface. So I can take them out 1, 2, 3 at a time. You'll notice that actually when I click on them, it'll reveal where the adaptive placement points are, the 1, 2, 3 points that are mapping to those curves. I'm going to take them out because we're going to regenerate them. So I got my surface. We are ready to start dividing this thing up. And as we start thinking about dividing that surface, the important thing is to really think about really how we can break it into a grid. And for the purpose of placing the adaptive beams, what we thought about doing is actually breaking it into kind of a 2-by grid. And the reason we're going with a 2-by grid is as follows. If we basically have in this gridding system, actually, I'll even open that back up in here so we can sort of see it a little bit better. If I take that surface, actually there's 2 surfaces right there, because it's sort of doing each sub-piece. Oh, there it is. Okay. And I divide that surface up. Okay. What I'm trying to do is basically come up with a grid that'll let me go through and pick 1, 2, 3 points that I can use as the beam placement points for creating those arcs. Okay, and then some number of points in this direction, which are going to be, each of those different grids in that direction is going to indicate where these beams are going to get placed. Let's see if we can sort of figure this out in terms of the directionality. If I had something which is only 2, okay, if I have 2 grid sections here and on the other side there, what I'm basically going to get is 3 different points, 1, 2, 3 points if I look at the grid intersections. And that's going to give me enough points to place the beams coming across that way. In the other direction, come back over there and see if I can get my little divided surface here. Oh, whether I make that 8 or 5 or whatever it is, what that's going to do is basically control the spacing between the beams. So I got the grid going in 2 directions. One way is really to go through and pick up the points that are going to be used to define how the beams will be placed. The other one's just going to define the spacing between there. Okay, so that's where I get this U and V and how I'm going to use them. And we're just going to do that directly within Dynamo. So just really choose a U spacing, a V spacing, and based on that, if we go through and keep it 2 grids wide, we'll always get the 3rd point there. Okay, that'll work out pretty well for what we're up to. Okay, the other thing we have to do though is then when it comes time to panelize this, we get to sort of think about, 2 different grids gives us 3 points, but ultimately gives us 2 panels. Okay, and kind of keep track of that because we always have the number of points, they're on the intersections versus the panels between the points. So you always have that funny relationship of you got a -1 in there all the time. So let me close this up and come back in here. So I got my surface hanging around in here. Let's go into Dynamo and we'll take a look at that. Actually, before we go down there, let's review just sort of the whole notion of the script about how we're doing this. And the basic control in the script is that we are going to go through and start by just selecting the face. That is the face that's coming out of the model. Then we're going to define the grid on the face and sort of say how many U's and how many V's to go ahead and divide it up. After we go through and divide it up, we need to go through and take that notion of the UV grid, which just determines, it returns values between 0 and 1, okay, and really map it to the XYZ space. That'll actually, for a location which is halfway across, it'll return the XYZ value in like a kind of true Cartesian space. And out of that, then we can go through and basically place these beams along that path, where we're going to go through and just take the list of all the points, break it up into groups of 3 so that we can sort of get the points and then place those points. Okay, so let's go ahead and do that and kind of show how that works. So again, if we're hanging around here, we go into the add-ins, we go to Dynamo. And we open up, go out to those session 6 examples. And I'm going to go to just the ending point on this one. Let's just take a look at how the scripting works. In fact, let me go ahead and run this. It's doing a little work in the background there. Actually, we'll see if it does run. It might complain at me because I'm not sure if it still has the surface. There, it looks like it still does. Let me go ahead and shrink this down a little bit so that we can sort of see what's going on in the background here. Yep, looks like it's actually doing okay. What I'm going to do is, just so we can sort of see it a little bit better here, is back over in the Dynamo environment, I'm going to do a little bit of watching here too. So for example, let's go ahead and in this environment, if I say Control G is always the thing that lets me basically take a look at the background preview. And I'm going to just zoom on or zoom out a little bit. You can actually see there really is that big grid there. What's happening is that little grid we always start out with like 10 by 10, so it doesn't show you very much geometry. That's kind of a better version of it. I can rotate that around if I want to. I'm going to Control G to get back to moving my nodes around. But you can see that basically what it's doing is it's placing a series of different UV points kind of just all over the surface. And it's doing it, it looks like there's 1, 2, 3. So kind of a 2 by grid over here. And then in the other direction, there's 1, 2, 3, 4, 5, it looks like. So it looks like there's 4 grids in the other direction. And if you take a look at that down into scripting here, you'll see where that's coming from. So we start with just basically grabbing that face. We change that face into something called a domain. And then within that, we just start dividing it up. We're dividing it up into 2 in the V direction and 4 in the U direction. And that's giving us a whole lot of points, and you kind of see them all over the surface there. Now, if you want to go ahead and take a look at those points, you'll see, actually, let me even go to put these little watch functions so you can sort of see what it looks like a little bit more publicly. Let's give myself a little watcher for those UV values. You can see that what it's returning is actually just a whole lot of dividing up the entire surface, you know, in 4 in one direction and 2 the other direction. So it's giving me all these points just everywhere from 0, 0 to 1, 1, and then all the points in between. So this is just defining a grid, like a perfectly flat grid. If I was just going to subdivide that space into a number of points, this is what it look like. So in the same sort of way, okay, if instead of having 4 divisions, and jumping from 0 to 0.25 to 0.5, 0.75, and 1. We switch that over to, say, 5 divisions or 6 divisions. Let me kind of do that. We let that run. You'll see the points are going to change. The points on the grid are going to change, going from 0.16, 0.33, 0.5. So these grids are really just picture the whole surface flattened out completely. It's really just dividing up the total space from one corner to the other, just in terms of all these different little grid coordinates. Okay, and what we got to do out of that, like that is kind of interesting from the standpoint of, just kind of mapping it out kind of on a perfectly flat surface. We just have to go through and convert that into the true XYZ points. And that's what that next function's about. So when we go through and we evaluate the surface, what we're going to do is then take that UV grid, apply it to the face, and actually return the true XYZ points. Okay, so let's put a watcher there instead. Again, we'll put a watch. I'll drag that in there. So here's what's happening in terms of how those different points actually get mapped out in XYZ space. So all these different things, the 0, 0 point, okay, maps to this XYZ set of coordinates. The 1 point maps to this XYZ set of coordinates. So it's just going through and doing that in terms of the true mapping the geometry. Yes?
What's the origin?
It's interesting. This guy over here, this is just actually the origin like on the surface, just like one of the corners of the surface. Okay, this origin over here, this is really actually just determined by where that surface is in Revit. Okay, so if we go ahead and move that surface in Revit, these things are going to move accordingly. Okay, so you know the fact that the 0, 0, 0 points at -65, -126, and 0, it's kind of interesting. Although, okay, you have me sort of wondering now, so let's go ahead and test it because I think that's actually a good question. I'm going to push this out of the way. So I got my little surface kind of hanging around over here in Revit. And the question is, if I go through and take that and I do some sort of move, okay, I would expect that when this thing runs at some point, it's going to do it. Doesn't look like it's updating itself, and that's sort of confusing me because I would expect that it would actually pick up the new values right then. Oh, is it doing its thing in the background? Oh, are they doing something in the background? Okay. Oh, did they already change? Well, it's faster than I'm thinking. Okay, so it's updating itself too. Okay, what happens now is once we have this list of values, here's what we got to do. Just in terms of understanding what it's all up to. So we got those XYZ values. These XYZ values are fantastic, except, you know, well, let's think about what they are good for and what they aren't so good for. As we go through and we track them in terms of what's going on, what we need to do is go through and ultimately, you know, this is just a big old flat list of points. It's just, you know, a list of, Lord knows how many points, 20 some odd points here, something like that. We're going to go through and just take that list and break it up into groups of 3. The reason we're breaking it up into groups of 3 is we need little triads of 3 points in order to place the component. Okay, so we're going to go grab element 0, 1, and 2 and put them into one little triad, put elements 3, 4, 5 and put them into another little triad, just kind of make little triads of points. Okay, and that's what the slice is all about. Okay, so what is slice doing? It's just going through and taking all those different little guys. Again, we'll put in a little watch in there. See if we can make that visible. So all it's really doing is taking those and grabbing them. So the first list, the second list, it's made a little sub list out of it. And that's what we need because then we're going to have this whole notion of 3 different points that can then be used by the adaptive component in place. So the slice returns this list of, there's really a curve, or really a set of 3 points, determined by those 3 points, There's a second kind of set of 3 points, a third set of 3 points. Those all get fed into the adaptive component, and that's how it actually places the beam across there. Okay, using those little sets of 3. So the reason we're dividing it by 3 is because for this specific component, it's looking for 3 points. If we had another component was expecting 4 points instead, we'd be dividing that by 4. The only really key thing here is you have to make sure that these sublists are really providing the correct number of points that are expected by the adaptive component. If you don't, then you sort of get yourself in trouble. So let me show you how you get yourself in trouble, or a way that you can get yourself in trouble in case this is happening to you. You'll notice there's actually this funky little function down in here where we took the grid and we divided it in a certain number of ribs and 2 spaces over here, okay? And what we actually did was, in order to convert the 2 to 3 to allow that for the number of grids, we have 1 more point than the number of grid spacings. We're adding 1 to it right there. And that sort of gets us into the form we need to be. If, on the other hand, we didn't do that, let's say, for example, I wasn't adding and I just left the 0 in there. Okay, what's going to happen is now it's feeding, or it's dividing the list up into groups of 2, and because it's up in groups of 2, this adaptive component's complaining that it doesn't have the right number of points to go through and place itself. So I'll say over here, let's see what it has to say for it. So, can you show me your error message? No. Turn it off for a second. Trying to get it to show me the message. It has a message, it's just not going to show it to me. Oh well, I'll let it be. But what we got to do is just make sure that we're always feeding the right number of points. Notice as we're doing this, the whole notion of throwing a lot of watchers in, it's actually a pretty good way of doing this in terms of really understanding what's going on and making sure you have the right behavior. Control G, let me get myself out of there. So I'll go ahead and put that back. It'll work as 1. Not that. Okay, it wouldn't work as 2 because, again, if I started feeding groups of 4 points, the adaptive component wouldn't know what to do. You just got to keep them in sync with each other. Okay, let us pause there and kind of talk about that one for a second, because the whole notion of basically breaking things up into these grids of points and then placing things based on those points is pretty, it's fundamental to what we're going to be doing here. So let's pause and think in terms of what's going on. In terms of, is it making sense? Is it sort of like, questions about that? Because what we're going to do next is just going to continue with the same example, but go a little bit deeper into the whole thing and say, okay, what if I didn't want to go through and just have linear sets of 3 points? What if I actually wanted to try and go ahead and put a panel on there that was going to use a collection of 4 points instead? Okay, so any questions? No? Ready to go? Okay, let us continue it then. So the next step in this whole process is saying, okay, great, we got that. Surface, it's looking pretty good in terms of what's going on there. Let me go ahead and just close up this Dynamo script. So here's the deal. We got our little surface here. We got the ribs hanging around. What I'd love to do now is have basically a panel, which is going to be between 2 of those different ribs, but actually have, well, we could go ahead and have just 1, 2, 3. Okay, we could have a whole number of panels along each of the different rib sections. If I wanted to just go through and have 2 panels on each section, okay, I could use, the same grid that we've already established. If I want to go through and have more than 2 panels, okay, then I might want to create another grid. One grid that's being used to determine where the beams are, and a second grid that's being used to determine where the panel breaks are going to be. Okay, so let's show you what this can look like. It all starts if you go over to hang on, let's again go to the add-ins, open up Dynamo. And how about as a starting point for this one, let's just going to open up the starting point on this one. Let's go again over to 6.3 or 6.2, I think it is, adding panels. Only for this one, rather than going to the end, let's go to start. So down at the bottom here of this script, this is actually the same script that we were working with before. Just choosing the face, taking that face, dividing into a grid. So 7 by 2 now, okay, giving ourselves some sort of UV grid. Based on that UV grid, evaluating it and creating that surface. And then slicing it up into 3 and placing those adaptive beams. So the bottom of this looks exactly the same as where we were before. What we're going to take a look at is up top, really what we want to do up there. And let's see how we can make sense of this. So up top, here's what we got to do. We're going to go through and create another grid. Only for this grid, we're going to go through and really figure out the number of panels that we want to have in each row. So let's start back over here and trying to go ahead and, oh, my mouse and I are just having a hard time with each other today. What is going on? I'm zooming. I'm not doing a very good job of panning though. And I'm not doing a very good job of clicking. I'm gonna do it over here. Now I'm zooming. I'm gonna close that up again. Something's acting strange, and I don't like it when things start acting strange like that. Again, opening that up, we'll go back to session 6. Let's go to the starting point of adding panels. Okay, so we're going to go through and create some sort of grid. We have the grid down on the bottom, which is the grid for placing the beams. We're going to have another grid up top that we're going to use for setting the number of panels in each row. So let's talk about that. So, depending upon what we want to have for the number of panels, okay, what we can do is set up an integer slider. If I went through and dragged that integer slider all the way down to, actually, probably shouldn't let it get down to 0. That would be kind of a bad thing in the scheme of things. I'll let it get down to 1. If it was only 1 panel big, okay, what would happen is, what I'm doing is basically picking up the V count. That's going to be the number of panels across a rib, okay, from the slider. On the other side, in terms of the U count, okay, we're just picking it up down here based on the number of ribs across the entire surface. So let's go ahead and just kind of take a look at, start with this and sort of see how, what it's returning so far. So I'll say, watch. Bring them on out. Let's run that. Okay, let's think of what's going on here. We have 1 going in that direction. We have 7 going in the other direction. Maybe even kind of make that a little bit easier for you. We'll make it like 4 going in that direction. Okay, So this looks pretty familiar here in terms of ultimately now we have 10 different points. It's going to be for 4 grids by basically 1 grid. So we have kind of points on either side. Let's kind of take a look at what that looks like back over here. How about this? Let me try like doing a watch 3D. And in this thing, it's not, oh, it's just giving me the UVs right now. It's not showing us anything in there. What I can do is actually, as soon as I take those UVs and I put them on a bunch of XYZs, that'll make more sense. U over there. Okay, so what I want to do is take all those UVs. I'm going to plug them in as the UV values, just like we did in the past. I need to go through and just plug the face in that we're able to work with. So that's going to map it across the face. This whole thing with my zooming is going to really continue to bother me. Okay. Where what I want to do is basically grab from that face, and I want to plug it in as the face over here. Okay, so see if you can give that a try. What we should be getting now is a whole series of different points. What's going to happen is just having a single grid, okay, because we basically said one panel across, okay, you're only getting points on the boundaries over here. If I start changing that now, if I start changing it to being 2 points across, or 2 panels across, hopefully you'll start seeing some more. If you start changing it to 3 or 4 or 5 panels, you'll see there's a whole lot more points showing up over here. So what is this doing? It's basically, we got 2 different grids going. They're sort of, one is on top of the other. There's the one that's sort of indicating all these points. There's the one that's indicating the points where the panels are being placed. In our case, what we're watching over here is the grid that's being determined, or that's being used to determine where the panels are going to be placed. Let me get rid of that guy for you right now. Okay, let's just pause there. So, okay, how's that feeling so far? We got this surface, we're just dividing it up into sort of more points across here, and now we have an integer slider that's going to go through and just determine how many panels are coming across that direction. Is that all feeling okay? Yes, got a question? Yes. Yeah, and the reason is we want one UV grid that's only going to have 3 points wide, or 2 grid sections and 3 points wide for doing the beams. I'm doing this other one because I want to have more panel points that are available for placing the panels along there. Okay, so it could have been the same, but yeah, it's a little bit different now. In fact, even here, just to make that really explicit, let's do watch 3D down here. We'll see if we can get the result of that for you too. And we run that. Run that automatically for you. There we go. So I'm not sure if you can see now, there's 2 different grid systems. There's a grid system where there's just 2 grids across, which is going to be for the beams. We got this one that's 4 across, it's going to be for the panels. Okay, and again, we can sort of change those 2 things independently. And again, we don't have to be worrying about the lower one so much, but just to understand why we have those, any number of panels, and the beam one is sort of staying independent. Okay, see, you can watch independent little subpieces of it. Okay, now we're doing pretty much okay. We have all these sort of X, Y, Z points that are coming out there. And what we did next, if we wanted to go through and figure out how to take these points and actually use those points to place something, is we sort of broke them up into little subsets. Okay, so slice was a really great way of just pulling 1, 2, 3 point, put it into a subset. 1, 2, 3 point, put it in a subset, because they're all kind of in a nice order and everything works out pretty well. Just kind of break them up that way. Okay. When we're doing the grids, though, for the surfaces, it's a little bit muckier in terms of what's going on there. Okay, so in terms of thinking about really how to break it up, yeah, we have a slightly different sort of behavior. The problem is we got this big old list here of all these points. A lot of points kind of hanging on that list. What I'd love to do is actually go through and grab, you know, the ones that make sense to be considered the corners of a panel. Okay, the 4 corners of a panel. And let's think about how you would even sort of describe that. Okay, make it a little bit simpler. And we'll think about how we describe that and then kind of see if we can just generalize it. So let's make it simpler in terms of, let's say there were only 3 panels in each row as a starting point. So I got this big old list of points. What I would really like to get from this list of points is to describe this very first panel down in the lower kind of corner. Okay, I'd like to get the very first point. I'd like to get the second point. Okay, I don't really want the third point yet. I don't really want the fourth point yet. I would like the 5th point and the 6th point, and that would be the first panel. Okay. For the second panel, I want the 2nd, the 3rd, not the 4th, 5th, I want the 6th and 7th. Okay, there's kind of a weird mathematical relationship to how you go through and you try to figure out, like, what are the corners of something, and it's based on really just how many points are in each of the rows, and then really as you're kind of moving through trying to grab them all. And we could go through and construct some incredible mathematical function to do that. Okay, that goes through and says I want to get the 4th element, the 5th element, and then do something else to grab all the different points. But it turns out that's kind of a messy thing to do. And the good news about messy things to do is very often people spend a little time programming that messy thing to do and put it into a function that you can then adopt. Okay, and that's part of the beauty of kind of the whole open source kind of share your code community, is that we can start doing things like that. And here's how that works in the world of Dynamo. It turns out there's a bunch of different things called packages. And within the world of what's readily available to you in Dynamo, there's all the ones that come as part of the standard installation. But it turns out there's a whole community of people out there developing other, if we were in Revit, we talk about library parts, going to Revit City and finding those. If we're here, you basically want to go out and look for little code snippets that do things that you might want to do. And let's talk about where that all exists. There's this funny thing called the package manager, and you want to know about that, and it all happens over here. You can search for packages, things that you want to grab. You can manage packages, sort of turn on and off different code modules that you want to have available. And what we wanted to go after and grab is actually something that makes what they call quads, okay? Or little quad groups as opposed to little triads. Okay, it looks like what it really wants to sort of have fed to it are a list of points. Okay, then it basically wants to know just how many are in each row. Okay, and once we figure out how many are in each row, it can then go through and do the math and say, oh, okay, so if every row has 4, super, then I'll break it up and I start to understand what the relationship between those things is. Okay, in terms of using that, let's start with how you actually find things like that. Okay. If you are in search of some functionality for something like our little quad manager or quad creator, here's what you do. You say search for a package, and then it goes out and looks for things. So if I typed in quad, What do we got here? We got quads from a rectangular grid, creates a rectangular grid of points on the face in a quad. Gives a, simple paddocks, groups of points from a list of UVs. There's a bunch of different little ones that are doing different things here. Measures the center point deflection for each group in a quad. Okay, there's different ones that are out there. What we're going to go ahead and use is the quads from a rectangular grid. Okay, and all I did was I said install it, and it pulled it on in. That's just a little more information about it. Okay, that basically installs it into our document here. Okay, and we're able to kind of work for it from there. Okay, if we want to go through and take a look at what sort of special functions, different macros are installed that are beyond the core functionality, you can say manage package, and you can go through and see that we have quads from the grid as one of the different packages. Not much else in there. Okay, let's close it up. Let's think about how we can actually use it. So in your sample model, do you have quads from a rectangular grid kind of hanging around in there? If you started with my sample, you probably do. If you didn't, we need to go ahead and search it and kind of bring it on in. But if you have quads from a grid, let's kind of see what it actually does. So what it wants to be fed is basically a list of XYZ points. So we'll feed it this list of points. I'll go for my XYZs. The other thing that it wants to know is just the row number. Yeah. Okay, do you have a quad from rectangular grid? Okay, no worries. Let's kind of think about what we need to do. Under packages, let's go under there. Let's go under manage packages and see if you actually have it installed. It's there? Okay, let's see if we can sort of make this work. It could be this thing about, and you're working on your own laptop? Okay, so that should actually work out okay. How about this? I'm going to go through and feed it row number 2. Actually, let's try installing it as a new node. I'm just going to take it out. Sometimes that happens when things get very confused. What I end up doing is I take out the old node and try putting it in there. So if you say quad, okay, from rectangular grid, and put it in as a node. Let's see if you can get it in as just a gray node. Okay, well, let's kind of think about, so there's different machines, and okay, so you're working on, one of the locked machines, right? One of the workstation machines. Yeah, okay, very good. And so we'll sort of debug it a little bit. So in terms of this quad, let me do Natasha first, and then we'll go ahead and get you, because we'll get them both. Okay, so yeah, are we able to pull it in and kind of make it gray? Okay, let's see if we can sort of find that. If you type in, let's see if it's actually installed for you. So if you type in quad over here and you say, quad from rectangular grid, let's see if you can actually get. Okay, so it's just not installed yet. No worries. Okay, so here's what we're going to do. On my machine, it's installed the package. For you, let's go ahead and you're going to say search for the package and type in quad, and then when you see quads from rectangular grid, let's install it. So it looks like it's not installed actually in the document. It needs to be installed into your environment. Okay, so if you can, go and do that. Now for you other guys, in terms of what's going on, you're working on these machines. Let's go back to, if we need to install it in this locked environment, okay, let's go ahead and do this. What we're gonna do is basically, if you're working on one of the workstation machines here, we're going to basically have you log back in a place where you can go through and make the change. Because I think it's actually, well, actually try this on your guys. If you do the search and you say install quads from rectangular grid, let's see if it'll let you install it. Okay, and it sounds like you tried installing it, but it didn't work, or what happened? Yes?
When I search for the library, it doesn't show up. Yeah, it's only the same, but doesn't have view.
Okay, well, let's kind of, so something's going on. Let's see if we can debug it. Is that, if you have installed it, okay, let's try this. If you go to packages and you say manage packages, let's see if it's there. It is there. Very interesting. Okay. What's up? And once the package is there, it should be okay. We'll try that. No, I think that actually is, I think about what the implication is there. Disclaimer, ready? That's kind of, okay. Did that help you with Hung? Did you to close it and reopen it? Okay, let's see if we can make that. Let's see what's happening with publish package. Okay, so, actually that may be another thing in terms of that. If you try the publish package, what happens? And we're just trying to sort of figure out when it does and doesn't update. Because it looks like publish package may make it available. Let's see if we can sort of figure this out. So how's it doing for you guys?
Yeah, once you close it and open it.
Very good. Okay, let's see if we can do that. So after we've installed it, let's see if we can get it back for everyone consistently. It's all the little hassles. How about you, Christopher? Is it coming? Yeah. Excellent. Oh, so go with, also under builds down there. There it is. Try clicking that one. There you go. Okay, do we got it? Whew! Okay, so what have we learned? So after we install it, we need to publish it or just close and reopen. Okay, so that we need to kind of, I guess, bring it into the environment so it's available for us. Very good. Thank you for everyone's help in debugging that, because there's always these things of great mystery, and you wonder why they work on some machines and don't. Okay, so let's see if we can sort of make some sense out of this. Okay, we got quads. Everyone got the quad thing? Any red nodes still? You're good. Okay. Okay, if you're ready to make your quads, here's what we're going to do. We're going to pass it in the points list. So grab the X, Y, Z's. And that's half of what it needs. The other thing we need is just how many different points are in each of the different rows. Okay, and that's what's going to help it do it. You actually happen to have a value that was very close to that. It's that old integer slider over here. Okay, so let's go ahead and try bringing that in. See if we can sort of make sense out of that. That's basically how many different quads, I should say, not points. How many different quads do we want to make out of each of those different rows? So in theory now, with any luck, we should have a whole bunch of different quads. Okay, so what it's done is it's just broken down all the different points and just kind of chunks them up into little sets of 4. So hopefully that'll do what we need. Okay, with that, we are almost ready. The final thing we have to do is basically, if we got a bunch of sets of 4 points, we basically have to just feed that sets of 4 points, okay, to a family type, and it'll adapt the components, place them out so they're all using those 4 points, and we need to go ahead and choose the appropriate family type, because the little baluster is just kind of a standard one. That's not going to be looking for the 4 different points. If you can, just do a little searching around in your list here. See if you can find, oh, there's something like adaptive panel. You got to find where it went. Simple beam, it's like Apple, it's like curtain panel aperture. There it is. DINS 08, aperture panel, that's it. Okay, that's going to be a panel that is looking for 4 points. How do I know it's looking for 4 points? Because back over here in the land of Revit, if I go through and edit it, I can see that it's a panel that basically has 4 adaptive points. Okay, 1, 2, 3, 4. Okay, so it's going to basically map that into that same space. So with any luck, I come through, I say, take those quads, plug them in as my XYZ group, let it do a little work, and hopefully it's going to start doing something interesting here. Okay, this as a very gross grid, we're going to think about what's going on here in terms of, I got 4 there, I got 1, 2, 3, 4, 5. It looks like I'm off in terms of my grids or my beams, and it looks like my kind of panel grid going in that direction look a little off from each other. I got to figure out why that is. Or is that just a case of some old ones that are hanging around? Let me, just for the purpose of this, I'm going to hide the math. That'll make it a little bit easier to see what's going on here. See if I'm going to dig on in here and see what's going on here. I think I actually have some old ones left over from before. So what I'm going to do is I'm going to take out these, which are the old beams from before I actually started this iteration of the example. Okay, and now with that as my little structure, I can go through and start mucking around. So if that's my little structure, you'll see that with the aperture panel, with just a grid which is only 3 panels wide, it's kind of a little deformy in terms of doing what it wants. It's an okay structural grid, but let's go ahead and see if we can change that. So as opposed to saying there are 3 panels, what if instead there were like 5 or 6 panels? Okay, that's going to get a little bit finer. In terms of what's going on. Now we can also start to think about the whole notion of, you know, the number of ribs going in the opposite direction. So we have like 5 or 6 panels going this way. It looks like I only have like 4 grid spacings going in that direction. If I want to make that a little bit finer, let's try that. So this is the one that's the ribs in the other direction. There's only 4 right now. Let's go ahead and bump that up to like 6 or 7. It's doing a little reorganizing back there. Now, the cool thing about this is the basic logic we're using is going to hold together. This whole notion of breaking it into 5 or 6 panels this way, you know, however many panels are going to go in the other direction, this is all going to hold itself together no matter what actually happens to the form. So in that same funny sense, if I go back over and I'll show that form, see if I can grab that form. Yeah, if I edit it, okay, and somehow make that form much more distended in terms of what's going on, and reload that back into the project. Okay, it is not quite up to date just yet. Oh, it's interesting. It looks like it lost the notion of where the face is right now. We go ahead and that's interesting. I would expect that it actually would just sort of continue to pick up the face, but it looks like it's a little off because I did the edit. What I'm going to do is, just because I've changed the form, I'm going to get rid of all the old ones just because I want to kind of have them all regenerated. So I'm going to get out the, leave the math, but take out those other elements just so I can start with a clean surface. I'm going to select the face. And hopefully it'll regenerate some geometry. It looks like it's working in the background there for me. And I'll hide that geometry again, or hide the math. you'll notice that there's a little bit of fineness in here. We might want to refine this a little bit. In terms of the structural elements, you will see that they are a little bit smoother. Okay, they're really defined by 3 points, where this grid is actually being defined by like 5 or 6 different points going across. So we can think about that in a number of different ways. Right now, the little beam elements, because this thing is so sharply kind of peaked, are a little bit separate from where the panels are. What we could do is we could go through and take that adaptive beam, okay, and add some more intermediate points on that so that we can feed it all the different points along there and really have it match the surface like more closely. Because right now, can you see what's going on? There's a smooth section, which is the curve. There's this very kind of segmented section, which is the panels, and they're a little bit off from each other right now. And it's because the beam is defined about the smooth curve between 3 points. Okay, and this is segmenting it a little bit further. Okay, so there's a little off between those two things.
I have a question. So if we want to apply this for a new building,
yes.
So the process is that we always have to clean this curves or because it automatically uses curves and it meshes it up. So we have to erase it. There's no process or in code maybe that we remove that. No,
it's actually this funny thing. The key to watch is when the relationship between the Revit elements gets severed. Yeah. What'll happen is, because I went through and edited the form, the old elements, since they were no longer associated, what happened was when I put the form back in, the new form that was in had like a new ID. Something about it was different, so it no longer maintained the association. So at that point, Dynamo didn't think it was still driving those parts anymore. What happens is, even when I sort of switch between examples but don't start cleanly, Dynamo will continue to control what it understands it's controlling, but it won't take out things, that it doesn't know about. So you can have these really weird mixes of parts that are controlled by Dynamo, parts that aren't controlled by Dynamo, just directly controlled. So it's a little strange in terms of then, you had to go through and do the cleanup. Whether you're sort of regenerating all from scratch, or whether you want to like somehow try to be smart about which ones came from Dynamo. You'd almost want like we need some cleanup function to go through. But a good question, and not at all outside the realm of what we could do. Okay, let us go ahead and break right there. If we can, go ahead and break for like 5 minutes and come on back. And when you do come on back, okay, this whole notion of going through and like taking these panels or taking these surfaces and sort of applying sort of adaptive components and adaptive panels to them, we'll kind of continue with that a little bit. We'll talk about how we can kind of continue to refine this, but also then shift our attention a little bit to, okay, this is sort of fine in terms of just sort of placing these things based on the geometry. How can we actually use things like, the sun's position to give us values that can start to change some of the values in the geometry? Okay, so go ahead and come on back in 5.